Good morning, class. Today we are going to start the new chapter, that is light. You have studied about light in your previous classes also, in 6th class and 7th class. You have studied about light. And if I ask you a property of light, I think the first property that you're going to tell me is the rectilinear propagation of light, isn't it? So you have studied that light travels in a straight line, right? And you have also studied the reflection of light, that when light is incident on a plane mirror, what happens? It bounces back. Here you are going to study a new aspect of light, that is refraction of light. So you might have seen certain observations, I can say. You might have observed. See what is given in your book. You can observe it right now if you want to. Take some water in a glass and dip a straw into it. What will happen? It will appear to you as if the straw has bent, isn't it? Similarly, if you dip something in water, suppose you have dropped a coin into water, what happens? Even if the coin has sunk deep into the glass or into the bowl or bucket, but it will seem to you as if it is somewhat closer to you, or it appears to be, the depth of it appears to be decreased, right? In the same way, if you see a bucket filled with water, the bottom of it appears to be raised up, right? This is all because of the bending of light, because light bends when it travels from one medium to another. The rectilinear propagation that you had studied in your previous classes, that was about a single medium, right? When light is traveling, suppose in air only, it will travel in straight line. In glass, in vacuum, or any other medium, water, okay, it will travel in straight line. But when it is traveling from one medium to another, in these cases, what is happening? Light is traveling from air to water, and when you see it is again coming back from water to air, that means the mediums are changing over here. That is why light bends. When it travels from one medium to another, it bends. That is why you see these things like the straw being bent or the bottom raised up. Okay, so all these things are because of the refraction of light. And what is refraction? That when light travels from one medium to another, it bends. Okay, so there are certain points I have written for you. So first of all, medium. What is a medium? Anything through which light travels is called a medium. Okay, so air, water, vacuum, glass, it may be some transparent plastic or something. Okay, then the bending of light when it passes from one medium to another is called refraction of light. Now, why does this refraction occur? Why does the light bend? Why doesn't it keep on traveling in the straight line? So if you remember, you might have studied that the velocity of light is 3 into 10 to the power 8 meter per second. Do you remember? You have studied this in your previous class, that the velocity of light is 3 into 10 to the power 8 meter per second. But this velocity is in case of vacuum. Okay, and this is the velocity of light is maximum in vacuum. When light travels in some other mediums like in air or water or glass, its velocity changes a little bit. Okay, now because of this change, what happens? That it bends, right? So because of the change in the velocity, light is bending. When it travels from one medium to another, its velocity changes, and that is why it bends from its path, right? Now there is one more term that you need to know, that is refractive index. Now see, in your book, after this thing, wherever they have shown this refraction, they have shown you a ray diagram. I am not going to teach you the ray diagram right now. I will teach you when we are done with all the terms of this thing, refraction. Okay, so can you see? This is the diagram in your book. So we will see it later on. For now, you can simply just know this, that this ray AO is the incident light, right? This is a surface, okay? This is air and this is the glass. This is the surface that is demarking this air and glass, okay? So below this line it is glass, above this line this is air. So AO is the incident light, and as it passes through the another medium, glass, it is bending from its path. What should happen actually? The actual path was like this, right? So it is bending from its path, OB. Okay, so we will be doing this ray diagram. I will tell you properly, but later on, once we are done with all the terminologies used in case of refraction, then I will show you the ray diagram. Fine. So there's another term, that is refractive index. Okay, so refractive index is something on which the bending of light depends. Okay, that means the light is going to bend less or more. That will depend on the refractive index of the medium. Okay, so what is refractive index? It is actually the ratio of the speed of light in different mediums. Fine. So refractive index is the speed of light in medium from which light travels upon speed of light in medium into which the light is going. Okay. So for example, see, suppose this is a surface, above it was air and below it was water, and this is the normal. Light is traveling, coming like this, and when it enters water, suppose it bends like this. Okay, then refractive index of water with respect to air will be speed of light from which the light travels. Okay, speed of light in air, it was coming from air, upon speed of light in water, speed of light into which it is going. Okay, so speed of light in air upon speed of light in water. This is refractive index. So this ratio will decide how much the light is going to bend. Okay, so this is the definition. Now see, whenever we are going to compare something, we should have some standard to compare with. Okay, like here, when I say refractive index of water with respect to air, I was comparing the refractive index or speed of light in water with the speed of light in air. Okay, so in the same way, I could say that refractive index of water with respect to glass, or refractive index of glass with respect to water, but we cannot going on doing comparing the velocity of light with any medium, no? So the standard is has to be decided. Vacuum is considered to be that standard. Okay, so if I simply say the refractive index of a medium is this, that means I am comparing the velocity of light here, of that velocity of light in that particular medium with the velocity of light in vacuum. Okay, so to define refractive index, what do we say? Refractive index of any medium is the ratio of speed of light in vacuum to the speed of light in medium. Okay, ratio of speed of light in vacuum to the speed of light in medium. So speed of light in vacuum is represented by C. You must be knowing it, right? c is equal to 3 into 10 to the power 8 meter per second. So speed of light in vacuum, it is not by c upon, in any medium we denote the speed of light with v, right? So, and see, this is the symbol of refractive index. You have to make a small n and just extend this end, okay? Then this symbol is known as, pronounced as eta, okay? So this eta is equal to c upon v. Fine. Now those mediums which have more or greater refractive index are said to be denser mediums, okay, and those mediums whose refractive index are less or smaller are called rarer mediums, okay. So in your book there are certain values given over here, like refractive index of glass is 1.5 with respect to air, okay. Then refractive index of water is 1.33. That means water is rarer medium and glass is denser, because the refractive index of glass is 1.5, right? So it is a comparative thing. So those mediums whose refractive index is greater are denser mediums, and those whose refractive index are smaller are known as the rarer mediums, right? Now there are certain rules of refraction. We'll just go through these rules. See the first one. The light bends while traveling from one medium to another only if it is incident on the boundary at an angle to the normal. Do you understand that? If the light is incident at an angle from the normal, see, suppose this is the surface, normal means if you draw a perpendicular on the surface, you will this is the normal, right? So if the light is incident along the normal only, it won't bend, okay. The light should incident at an angle with the normal, then only it is going to bend, right? So this is the first rule. Second one, light bends towards the normal when it travels from an optically rarer to denser medium, okay. And when light bends away from the or you can say when light enters from denser to rarer medium, it bends away from the normal. Fine. So you have to remember this. If light enters from rare to denser medium, suppose this medium is rare and this one is denser, what will happen? When light enters the other medium, it will bend towards the normal. Can you see? The path was like this, but instead of going that way, it bended towards the normal. So when it is entering from rare to denser, it bends towards the normal. Now suppose light enters from denser medium to rare, okay, it is entering like this, it has to go to the rarer medium. Now what happens? It will bend away from the normal. It had to go like this. The actual path was this, so it will go bend now away from the normal, okay. This is how the bending of light takes place. So now you can understand this ray diagram better. See here, there is this medium air, that is the rarer medium, then glass. See, the light ray is entering along this ray. Let me name it here O, okay, in both the cases. So light is entering along AO, and because the this medium was denser, so it is bending towards the normal. In this case, the light is entering along BO. From the denser medium it is entering, okay. So going toward in the rarer medium, what happens? It bends away from the normal. and the angle between the normal and the incident ray will be called angle of incidence, as you have studied in case of reflection. Okay, and the angle of refraction is the angle between the normal and the refracted ray, right? And this thing is reversible. Okay, so see, in both these cases what they have done, they have, in this case they have simply reversed the arrow, direction of the arrow. So whatever was happening from rare to denser is happening from denser to rarer. So in this case simply the angle of incidence and angle of refraction have changed. Now this is I, this is R. Okay, so these ray diagrams are reversible. This is how the refraction takes place. Now there are another things, effects of refraction in other things. So we will be studying these things later on in other classes. That's all for today, children. Bye bye.